A cost-income equation is a common linear modelling problem that we can come across quite often, and we can actually solve it really easily using our simultaneous equations graphing method. Okay, so I want to take you through an example, and this example has really commonly asked questions that you'll find. So what you'll need to do is have a read of the problem. Okay, you'll usually be asked to come up with a linear function or an equation for the cost. You'll also need to find a separate linear function for the income. So you're actually creating your two equations that you will then solve in order to be able to answer the problems that come later. Okay, so this, as I said, is a really common problem, and they usually follow this process, but it is super important that you're able to recognize that you need to form two separate equations. Okay, so let's have a look at the example that we've got here today. So Cherie sells scones for $3 each. It costs her $240 for the necessary equipment and $1 to make each scone. So we want to find a linear function for C, which is the cost in dollars for making N scones. Okay, so we're going to have our cost is equal to, so we need to look at the info that we're given. The scones cost $3 each. The equipment costs $240. So the $240 is our fixed amount. Okay, so it's going to cost her $240 no matter what, because that's the equipment she needs to use for the scones. So she is going to have to pay $240 no matter what, and it costs her $1 to make every scone. So not to be confused between the selling price of the scones and the cost the scones are to make. All right, so our fixed cost is $240, plus then we've got obviously our number of scones and multiplied by $1, because as I said, each scone costs $1 to make. And then we just obviously simplify that, nice and straightforward. C is going to be equal to 240 plus N, and then just because we're going to be really pedantic and we like our linear equations in a very particular format, we're just going to swap the position of N and 240 so that it is in gradient intercept form. Okay, so we have C equals N plus 240. So nice and straightforward for the cost of each scone. All right, so then we need to find a linear equation for I, which is obviously the income in dollars for making N scones. So same thing, we look at, well, how much money is coming in for every scone that Cherie makes? She sells them for $3 each. So really simple, our income is going to equal N times, can't write, $3, which in simplest form we write as income, or I, equals 3N. Okay, nice and straightforward. So then we're usually asked to graph the functions together. They've been quite kind in this question, and they're asking us to graph for particular values of N. Sometimes you do need to work out what would work best for you in terms of your graphing, okay? But I've got a grid here, okay, where I've got my N values all the way up to 200. I've just gone up by 20s to fit them onto this graph, and then my dollar amounts are just going up by 50, okay? Super duper important that you have your scale even on the horizontal axis. Your scale also has to be even on the vertical axis. The scale, though, does not have to be the same on the vertical and horizontal axes. Okay, you can, as I said, my number of scones is going up by 20s, my amount's going up by 50s. That's perfectly fine, as long as each increment is the same on both the vertical on the vertical axis, and they're all the same on the horizontal axis. Okay, so I'm going to actually use my tables of values that I've got up here just as a quick reminder of my equations. So I've got my cost equation, which is C equals 240 plus N. My income equation is I equals 3N. Of course, this is N plus 240. That was silly. All right, so then I'll just graph, I'll just put different X values, or in this case, it's N and C, and my different N values, C, my N values, and my income amount. Okay, so I'm just going to take N is 20, 40, 60, 80, 100, and again N 20, 40, 60, 80, 100. Okay, so I input each N value into my cost equation. So I've got 240 plus N, where N is 20, so 240 plus 20 gives me 260. My boxes are a bit small for these numbers. 240 plus N is 40, so 240 plus 40 is 280, and so on. We can see it's going up by 20s. So I've got 300, 320, and 340. Okay. Then for our income equation, we know I equals 3N. Okay, where N is 20, 3 times 20 gives us 60, 3 times 40 is 120. So you can see these values are going up by 60, so you can continue to calculate it, or you can use the pattern as long as your pattern in your N values is the same, which ours is this time around. So 180, 240, 300. Okay, so I have two tables of values that I'm going to use to graph my functions. I'm going to graph the two lines in two different colors. Okay, obviously I got my favorites, pink and purple. It is best to graph the two equations in two different colors, just so it is absolutely clear to you which one is which. It's not the end of the world though if you only have one color, but just make sure you label your graphs. Okay, so we're in our cost equation where N is 20, our cost is 260, which is about here. Okay, 40 to 80, which is about here, thereabouts. 60 and 300, good. That's nice and easy. And then I'm just going to skip to 100 and 340. So it's really important to note that you don't actually need to graph every point from your table of values, as long as you can use your ruler to make a straight line with the points. Okay, so going to look a little something like this. Obviously my graph is a bit off because of the estimation, but that's okay. All right. We have, of course, our label, C equals N plus 240. Change colors. All right. I'm going to plot my easy one where N is 100 from my table of values. I have an income of $300. So 100 up to 300 takes us right here. And of course, my income, when N equals 0, when I'm not making any scones, I haven't made any money. So what's going to happen with the income is that when no product is made, it's 0. So you can actually really, really simply graph the income equation because you've got your two values and it's going to run through the origin. Okay, because obviously you cannot make any money when you haven't made any product. So I join my two values. Now this one's going to be perfect because it's on the intersection of the lines. As long as I can use my ruler properly today, which is sometimes difficult. Okay, so remember, label I equals 3n. So that's my two equations, okay? I have my cost in pink and my income in purple. So it's really important that we're able to understand what these graphs actually mean, okay? We have our income starting very low and it ends up meeting the cost equation and overtaking it, okay? That's what we really want to happen, okay? Obviously our costs, they start at 240 and they do increase, but they increase at a slower rate, all right? So what this means, at this point where the graphs intersect is where, what's her name? Cherie actually starts to make money. It's where her costs are no longer greater than her income. So what's happening in this section, because her costs are greater than her income, the pink line is higher than the purple line, she is not making money, okay? This point here where our graphs intersect is called our break-even point, and that's a really important term to learn and remember, okay? That's where the business begins to make money. It's no longer costing them to produce. Once they sell over that amount, they start making money, okay? And in this section, we start making a profit, okay? So that's our profit happening there. And this is obviously loss. They are losing money until they sell. And my break-even point occurs where the graphs intersect. And if we have a look, our graphs intersect right here at n equals 120. And our cost is our amount is 360. Okay, so what does that tell us? Let's go back to our questions. We've graphed both functions, good. So how many scones does Cherie need to sell to break even? So we need to get to this point. She needs to sell 120 scones, okay? So to stop losing money, she needs to sell 120 scones. All right, so how much profit will Cherie make if she sells 390 scones? Well, if we have a look on our graph, we only graphed up to 200 scones, okay? So what we need to do is we need to work out how much income she would get from 390 scones. So we use our income equation, which is income, of course, equals 3n. In this case, n equals 390. So 3 times 390, which is going to be $1,170. Okay, how much will it cost her? Because remember, we want to work out how much profit she's going to make. So that's going to be the difference between her income and her cost. Okay, so we do need to take our cost away from the income. The cost equation, remember, is n plus 240. In this case, n equals 390 plus 240, which is 630. So it's going to cost her $630 to make the scones. She receives $1,170 from selling the scones. So her profit is going to be 1170 minus 630. And that leaves her $540. Okay. When 390. Scones are sold. All right. Remember, when you're asked a question in words, it is really important to give your answer in words. Okay. Hopefully that's helpful. Breaks down some of the confusion around cost-income equations. Remember, it's super important. You need to form your two equations. You cannot solve these problems without having your two equations. Hopefully this has been helpful. Give it a like if it has, and you can, if you want to see anything else, you can comment below and let me know, and I will do my best to get it uploaded for you.